Welcome to lesson 122, prime numbers and prime factorization. Today's objectives, I will be able to find factors of any given number, find the prime factorization of a given number, identify composite numbers, and identify prime numbers. All right, so the first thing that we need to know, first of all, is what is a factor? We talked about this a little bit in lesson 121. How factors are different in multiples is they are whole numbers that divide a non-zero number without a remainder. So a whole number that divides a non-zero number without a remainder. So like for 6, the factors of 6 are 1, 2, 3, and 6 because each of these numbers can divide 6 without a remainder. So they're the numbers that you put together to make up this number. So remember, factors have to do with division, multiples have to do with multiplication. A composite number is a whole number greater than 1 with more than 2 factors. Okay, so it has to have more than 2 numbers inside of these parentheses, and we do use parentheses to indicate that these numbers are in fact factors. Right, so an example of a composite number would be 6 because it has 4 factors. A prime number is a whole number with exactly 2 factors, 1 and itself. An example of a prime number would be 2 because the only numbers that divide 2 evenly are 1 and 2. So 2 is a prime number. And prime factorization. Prime factorization is a number written as the product of its prime factors. So we're taking the factors and we're writing them as a multiplication problem to get prime factorization. So the prime factorization of 24 would be 2 times 2 times 2 times 3. And because 2, 2, and 2, and 3 are all prime numbers, when you multiply all of them together, they give you 24. All right, so let's start with factors. How do we find the factors of a number? So we're going to start with 12. You always start with 1. So the first factor of every single number is going to be 1. 1 is a factor of every single number, every single whole number. Okay, so we start off with 1. Then we always end with the number you are factoring. So since we're factoring 12, our last number would have to be 12. Then we'd start to think about every number that's in between each of these numbers. So I think next is 2. Is 12 divisible by 2? Okay, and if you remember your divisibility rules, you know that since 12 is even, it is divisible by 2, therefore 2 is a factor of 12. So then now I think, okay, well 2 times what gives me 12? So whatever I would multiply 2 by to get 12 would be my next factor over here. So I kind of go smallest, biggest. So I have my smallest one and what I multiply to get 12. My next smallest one and what I multiply to get 12. And in this case, I would multiply by 6. Okay, so now I continue with step number 3 and I think of everything between those two numbers. So the next number in this case would be 3. Since 12 is divisible by 3, I write down 3 and I think, what do I multiply 3 by to get 12? In this case, I multiply 3 by 4, so I know that 4 is a factor of 12. Okay? And then when there are no numbers between, that works. So there are no numbers, no whole numbers between 3 and 4. So I'm all done. And I can check my work by saying, okay, do I have something to connect with 1? Yes, 1 and 12. I can use my factor rainbow. 2 and 6, 3 and 4. And then I always need to remember to put my parentheses around the outside. That is what shows that these numbers are indeed factors. Alright, so let's list the factors of 15. So again, I start with 1 because I always start with 1. And then I write 15 because my smallest factor will always be 1. My largest factor will always be the number itself. Okay, give yourself lots of room. You can always rewrite the answer if you have extra space. It's always hard to squeeze numbers in if you leave yourself not enough space. So now I think of 2. Is 15 divisible by 2? Well, I'm not sure, so let's do some division. 2 goes into 15. 7 times minus 14. I get a remainder of 1, so 2 is not a factor of 15. So now I try 3. Is 15 divisible by 3? Yes, it is. It goes into it 5 times, so I'd actually put the 5 over here. Now I have to think of what's next. 4. Is 15 divisible by 4? We can try it just in case we're unsure. It goes in 3. Nope, I have a remainder, so 4 is not a factor. And since the only whole number between 3 and 5 is 4, I know that I'm done, so my factors are 1, 3, 5, and 15. And because this number has 4 factors, it is actually a composite number. Okay, so what I would like you to do, you have 27 and 36 and 42. I would like you to try those problems on your own. When you come back, we'll go over your answers. All right, for 27, I have 1 and I have 27. So I kind of think the further apart the numbers are, the more space I give myself. Sometimes it's a good rule of thumb, sometimes it doesn't matter. So now I try 2. Well, since this number isn't even, it's not divisible by 2, so 2 is out. Now I look at 3. 7 plus 2 gives me 9, and since 9 is divisible by 3, 27 is then divisible by 3. That's one of my divisibility rules. If I can add these two numbers and they give me a multiple of 3, then I know that this number is divisible by 3. So then I go up here because I'm not quite sure what that number would be. 3 goes into 27. Let's try 7. Nope, I still have more left over, so 7 doesn't work. Why don't I try 8 then, because I had 6 left over. Nope, still have 3. So in this case, 9 times 3 is 27. I have 0 left over, so my other factor is 9. Okay, so then I try 4. 27 is not divisible by 4. Okay, because I know if I do times 6, that gives me 24. So that doesn't work. It doesn't end in a 5 or a 0, so 5 doesn't work. It is not divisible by 6 because the closest we can get with a 6 is 24. It is not divisible by 7. It is not divisible by 8. And I already used 9. So the factors of 27 are 1, 3, 9, and 27. So even though this number is odd, it's still a composite number. Okay, so don't just think because a number is odd that it's prime. It doesn't always work that way. Right? And if you haven't done so yet, you can pause and try 36, or I can just show you the answers. So for 36, it's 1, 2, 3, 4. 6, 9. So 6 times 6 is 36, 4 times 9 is 36, 3 times 12 is 36, 2 times 18 is 36, and 1 times 36 is 36. And this one is composite. And last but not least, you have 42, which is 1, 2, 3, 6, 7, because 6 times 7 is 42. 3 times, well, I'm not very sure, so I'm just going to go up here and do the division. 14. See, now I don't have to try 8, 9, 10, 11. Once I find these two middle numbers that connect, then I can just start connecting my outsides. Okay, and I know 2 times 21, and then 1 times 42, and again this number is composite. Okay, so now I want you to look at these and I want you to determine if they are prime or composite. So I want you to pause. You're going to need to look at the video because the numbers are all up here, but I want you to pause. Okay, and I want you to write the numbers in the boxes where you believe that they go, and when you come back, we'll check your answers. Right, in this case, 29 is prime, as it does not have more than 2 factors. 6 we know is composite from our notes. 11 is prime. 13 is prime. 17 is prime. 21, 2 plus 1 is 3. Since 3 is a multiple of 3, it's divisible by 3. So I know 21 is composite. 23 is prime. 28 is composite. 27 is composite, because remember it's divisible by 9. 25 is composite, it's divisible by 1, 5, and 25. 19 is prime, and 14 is composite. Alright, so there are 2 methods for prime factorization. Okay, they are the factor method and the tree method. So when you're using a factor tree, I really like the factor tree. So you start off with your number, and I think of that as the star on my tree. And then I break 48 into any multiplication problem that I can think of. So I know that 12 times 4 gives me 48. So now I break up 12 into any multiplication problem I can think of that gives me 12. And I know that 4 times 3 gives me 12. Now I have to try and break up the 4. And I know I can break up the 4 into 2 times 2. Okay, so anytime I have a composite number as a factor, I have to keep going. But since 2 is prime, I'm going to go ahead and circle it because I know I have to use it in my prime factorization. I also know that 3 is prime, so I have to use that in my prime factorization. Now I go up to the 4, and I see that I can break up the 4 as 2 times 2, both of these being prime, so I circle them, makes it easier for me. And then I take all of my ornaments, all the circled numbers, and I make them into a multiplication problem from greatest to least. So I have 1, 2, 3, 4 2's, so I do 2 times 2 times 2 times 2. Okay, so that's all 4 of my 2's. And then the last one is times 3. So the prime factorization of 48 is 2 times 2 times 2 times 2 times 3. Now I can also do this with the ladder method. The ladder method you guys learned with least common multiple, except for this time when you have a number on the outside it has to be prime. So when I divide, I have to divide by a prime number. So in this case I'm going to divide by 2. I know that 48 divided by 2 is 24. I know that 24 is divisible by 2, which is prime, so all the outside numbers have to be prime. 24 divided by 2 is 12. I'm going to divide 12 by 2 again because 2 is prime, and 12 can be divided by 2, and I get 6. 6 can also be divided by 2, and I get 3. And I know 3 is divisible by itself, which is 3. And that's a prime number, and I get down to 1. So now I know I'm done. So I take these numbers on the outside of the ladder, and they are my prime factorization, which again gave me 2 times 2 times 2 times 2 times 3. I know this is a little bit difficult, but with practice, I know that you'll become very good at it. And I know a lot of students really like the tree method, and that's just fine. I prefer to use the tree method. It's just a little bit less complicated for me, but whatever problem works or whatever method works better for you is absolutely fine with me. I just ask that you try them both. Right, so what I want you to do is I want you to try all three of these using the tree method, and then when you come back, we'll go over your answers. Okay, so 12 can be broken down into 6 times 2, or you could have broken it down into 3 times 4. 6 would have been broken down into 3 times 2, all of these being prime. In this case, 4 would have been broken down into 2 times 2, so you can do this in many different ways, but you still should have gotten 2 times 2 times 3. 24, I'm going to break it down into 12 times 2. 2 is already a prime number. I can break down 12 into 3 times 4, because 3 is already a prime number. And I can break this down into 2 times 2. Any way that you did it, you should have ended up with 2 times 2 times 2 times 3, which makes sense because since 24 is double as much as 12, or 2 times 12, it would make sense that I have one extra 2 in here than I did in here. 32 I broke down into 4 times 8. 4 breaks down into 2 times 2. 8 breaks down into 2 times 4. Circle the other 2. I break that down again into 2 times 2. So in this case, the prime factorization was 2 times 2 times 2 times 2 times 2. And I count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that is how I find the prime factorization using the tree method. Now, of course, you can have different numbers here just as long as they multiply and get to that top number. And your answer should still have come out the same as what I got down here. So this is important, but this is the most important. So if this looks different than mine, that's okay as long as this looks the same as mine. Okay, and now I'd like you to try finding the prime factorization of these three numbers using the ladder method. When we come back, we'll go over your answer. All right, 18 I know is divisible by 2. I like using 2 because I know it's prime, and I'd never get confused with that. Okay, but 18 divided by 2 is 9. I know 9 is divisible by 3, and 3 is a prime number. 9 divided by 3 is 3. I know 3 is divisible by itself, and 3 is a prime number, so I get 3 divided by 3 being 1. So the prime factorization of 18 is 2 times 3 times 3. Oops, look at that. See, I even tried to use the tree method. I like it so much. 100 is divisible by 2. I get 50. 50 is divisible by 2, and I get 25. 25, not divisible by 2, but it is divisible by 5, which is prime, and I get 5. 5 is divisible by itself, okay, which gives us 1. So we always want to get down to this 1 down here. So now I take these outside numbers. It's 2 times 2 times 5 times 5. And a way to check is to actually do the multiplication. 2 times 2 is 4. 4 times 5 is 20. 20 times 5 is 100. So as long as you get back to this number, you did it correctly. 75 I know is divisible by 5, and that's going to give me 15. 15 is also divisible by 5, which is going to give me 3. 3 is divisible by itself, gets me down to that 1 that I'm always looking for. And my prime factorization in this case would be 3 times 5 times 5. Again, you could have a 5 here, a 3 here, and a 5 here, and that's okay as long as this matches at the end. Okay, and don't forget you're going to get time to work on this and practice it in class, so if you're struggling right now, it's okay. You're going to practice it again on your own, and you'll have time to practice it in class this week. All right, so what I would like you to do here, I would like you to use either of the two methods. You can use the ladder method or the tree method to find the prime factorization of each of these numbers. And then what I would like you to do is go on to Edmodo, and this will be on your quiz on Edmodo. As always, if you have any questions, be sure to post them to Edmodo so we can go over them in class tomorrow.